All right, sorry about that. Got cut off. So when is tangent 1? All right, so this is the second part of the videos here. So we asked, when is tangent 1? Well, let's see. Tangent is 1 at pi over 4, but it is also 1 at 5 pi over 4. So you keep that equal to 2 theta, and then you solve like you normally would. So I'm going to divide by 2, and you're going to divide by 2. And when you divide by 2, then it's pi over 8. And this is 5 pi over 8, and there are your answers. Pi over 8 and 5 pi over 8. Now you may be looking at that going, what? But trust me, pi over 4 divided by 2 is pi over 8. 5 pi over 4 divided by 2 is 5 pi over 8. And that would give us 1. So if we took the tangent of 2 theta and we put pi over 8 in there, it would be the tangent of pi over 4. And that's 1. Because 2 times pi over 8 would be pi over 4. 2 times 5 pi over 8 is 10 pi over 8, which would be 5 pi over 4, which the tangent of 5 pi over 4 is 1. Okay? All right, now this is where it gets a little scary, these 4 particular problems. Because we no longer limit our answers to values between 0 and 2 pi. Say what? Okay, now we're going to actually solve this for all values of pi, all the angles of theta, of all the angles of theta. We're going to find all of them, not just 0 to 2 pi. Now you're asking, probably scratching your head saying, what? How are we going to do that? Okay, well, I'm going to show you. Well, the first thing on number 1, I recognize a cosine squared and a sine. Well, that definitely isn't going to, we're not going to be able to do anything with that. So we probably need to change our cosine squared to something else. So look, what is cosine squared? Well, if you recall, it's 1 minus sine squared theta equals 3 sine theta plus 3. So we're going to substitute. Now we have nothing but sines. So we're going to distribute the 2. And then we're going to get everything on the right side. And the reason is that makes that negative 2 sine squared positive. And then 3 minus 2 is 1. So we get a quadratic now. A is bigger than 1, but this 1 makes it pretty easy. So this is really 2x squared plus 3x plus 1. So if I'm just going to double bubble this, it's pretty darn easy because they both have to be positive. 2x plus 1, x plus 1. Why? Because positive 1 times positive 1 is 1. If I check the outers, it's 2x, and the inners is 1x. That adds up to 3x. So I know my factors are right. So x equals negative 1/2 and x equal negative 1. Now what did x equal? Sine, right? So sine theta equals negative 1/2. Sine theta equals negative 1. Well, when does sine equal negative half? Take the inverse sine to figure that out. Take the inverse sine. Okay, sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. I'm just looking at the unit circle. When is sine negative 1? Only one place, 3 pi over 2. But we want all the answers, meaning we can go around the circle 100,000 times and still get an answer. We want every single answer. Well, that kind of blows our minds because that means we'd have to list them all. No, that's impossible, isn't it? We'd be here, till the end of days trying to figure that out. So what we're going to do instead is we're going to say, okay, every 2 pi sine repeats. Every 2 pi. So whatever answer we have, we're going to add 2 pi to it. So these answers then are going to read like this. The first answer is going to be 7 pi over 6 plus 2 pi k. K meaning how many times do you want to go around the circle? You can go positive, you can go negative, it doesn't matter. We're going to take that times 2 pi and add 7 pi over 6, and it's going to put us at that solution every time. Okay? The next one would be 3 pi over 2 plus 2 pi k. The next one would be 11 pi over 6 plus 2 pi k. Those are the answers to all of our questions, all of our thetas. That's how we would find any answer that satisfies number 1, plus 2 pi k. Now, if it was tangent, I want you to think about it. If it's tangent, you only have to add pi, because tangent repeats every pi. Sine and cosine repeat every 2 pi. So let's look at number 2. Sine 2 theta equals sine theta. You're like, what? Yeah, me too. I can't divide by sine theta. That doesn't make any sense. But I can change sine 2 theta to a double angle formula, which is 2 sine theta cosine theta equals sine theta. Now, if you recall from last, 3 weeks ago, we don't want to lose sine. We can't divide by sine because we will lose an answer. So let's subtract sine from both sides, and then let's factor out a sine, GCF, and we're left with those factors. Take out a sine, you're left with 2 cosine minus 1. So now sine theta equals 1, and I'm just going to go ahead and do the math right away. Cosine theta equals a half. Add 1, divide by 2. So we're going to do the inverse sine and the inverse cosine. Now, when is sine 1? Well, that would be what? Pi over 2. It's the only time, isn't it? When is cosine 1/2? Pi over 3 and 5 pi over 3. Now, those are our answers from 0 to 2 pi. We need the answers, all of the answers, in other words. So the first one, pi over 3 is the smallest, plus 2 pi k, because cosine repeats every 2 pi. Pi over 2 plus 2 pi k. 5 pi over 3 plus 2 pi k. That gives me all of the answers for theta. All of the angles of theta will be found, adding 2 pi as many times as you want. K is just a constant. That's why we use a K. It means constant, any constant number you pick. Okay, now 3 is just awful, but I see a 3 sine squared, which makes me think cosine 2 theta probably should be changed to 1 minus 2 sine squared theta so that we get nothing but sine squared. Now that makes sense. Let's see if we combine like terms. I think we end up with that, don't we? 3 sine squared minus 2 sine squared is 1 sine squared. Negative 2 plus 1 is negative 1. I'm going to add 1 to both sides, and then I'll take the square root. Sine theta is going to equal plus or minus 1. So when I take the inverse sine, I want to know when sine is 1 or negative 1. Well, that only happens at pi over 2 and 3 pi over 2. Now, I want you to think about something, though, before we add 2 pi k. Your answers are here and here. How far are those apart? 1 pi, right? So I literally can get every answer by just doing pi over 2 plus pi k. That gives me every single answer. Because if I put in 0 for k, 0 times pi is 0, I'd get pi over 2. Let's put a 1 in there. Pi plus pi over 2 gives me 3 pi over 2. Are you following this? See how we get every one of them as we go around the circle? Okay, so this is all we need for this particular problem. I would not count it wrong if you put pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k. It is redundant, but I wouldn't count it wrong. Okay, and the final one, cosine squared theta equals 1/2. I'm going to take the square root, and I'm going to get the plus or minus radical 2 over 2, because that's going to be 1 over radical 2. And 1 over radical 2 is radical 2 over 2. Now, when is cosine positive radical 2 over 2 and negative radical 2 over 2? Here again, you got to be careful on this, because they're 180 degrees away from each other. So how far? We know the one answer is pi over 4. So what's the next? Let's see. If I added pi over 2, it would give me the next answer. Pi over 4 plus pi over 2k. Because it's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, we would just keep adding pi over 2's. See that? 90 degrees each time. And we could go around the circle forever that way. Now, if you're not comfortable with that, which I don't know that you are you comfortable with that? That would give me, that would give me pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, and then I could do 3 pi over 4 plus pi k. And that would give me 7 pi over 4, 11 pi over 4. It would give me all of the other ones. So either one of these two would work. And yes, you could use 2 pi k, but then you would have to do pi over 4 plus 2 pi k, 3 pi over 4 plus 2 pi k, 5 pi over 4 plus 2 pi k, and 7 pi over 4 plus 2 pi k to get all the answers, where you can trim it down to just that. Every half a pi is an answer.